Okay, so this is just a quick sort of idea on how to explain Sanger sequencing and the way that we do it. And so I go through the whole idea of how you use in DT, NTPs, all right, and every time one of those attaches randomly, so say on your sequence, first letter is A, and so one of those attaches at the first sequence, you conceivably get a piece of DNA that is just one nucleotide. So the resolution I know is not that good, but just for illustration purposes, let's say that it goes through and the first nucleotide is A. So now you have a one nucleotide sized piece because the chain will not continue on because there's no OH, there's no hydroxy group on the end of this, so it can't keep making the chain. And so that would be the first letter in your sequence, right? Because otherwise it would just continue on and make the intervening ones from the regular DNTPs, not the DDNTPs. And so it would go along, and then somewhere in there you would end up with a fragment that would be a single normal nucleotide and then our DTNTP. And so this one is too long, so it's telling you, right? And so that's going to continue on. You're going to have all these different sizes, and then when you send them through that thin polymeride, what's going to happen is they're going to arrange themselves from small to large, right? Small ones are going to go through first, large ones are going to go through faster, large ones are going to go through slower. And so what ends up happening is they line themselves up by their size. So the A would go through first, and that green fluorescent, it'll go by an electric eye with the laser, and that green fluorescence gives you a little peek at A, right? And the resolution is high enough in that gel that it'll resolve into individual, a difference of individual base pairs. And so the next one through, so if the first one through is a single A, the next one through is going to be this one, that's 2, and then our T will give a peak. And so that next little peak will be a T, right? Because it won't read this normal base here. It won't read that one. You've only got that one T there. So it tells us that that next one is T. And then the next piece, which is one more base pair bigger, is going to be, that one's going to go through. All right, and so we've got 2 normal bases. We already know what those are, but so our next peak is going to be a blue because it's going to be our C. It's going to continue on down the line, right? And then I don't have my little dots, but it's going to be the 1, 2, 3, 4 base pairs, and then the 5th one is going to give you a little peek at the G. So what I want to do is maybe set this sort of thing up as an actual activity with the students with, let's say, like pool noodles, and then the fluorescent tagged base DTNTP on the end of it, right? And then they'll have to line themselves up. So, okay, who's got the shortest, who's got the next shortest, who's got the next shortest, and down the line, and then we can actually read what the sequence is. So I think that's worth trying out.